everybody, welcome back to chapter 11. This is lesson 8, just part 2, because I couldn't squeeze it all in. And before I forget to tell you, in addition to watching these videos and doing the practice that we're doing together, I would like you to do question 48 out of your textbook and question 58 out of your textbook. Just 48 and 58 from chapter 11. All right, so this is another type of problem that deals with osmotic pressure. It says determine the molar mass of a certain protein if 0.001 grams of it was dissolved in enough water to make 1 liter of solution. So we have 0.001 grams of the protein that we dissolved in 1 milliliter total of solution. The osmotic pressure is 1.12 torr at 25 degrees Celsius, which of course our temperature always has to be in Kelvin. So we add 273 to that, and we get our 298. Okay. Calculate the molar mass of the protein. So they're asking us here for molar mass. So if we think about the equation that we know for osmotic pressure, it's molarity times R times T. And what molarity really is moles of solute. In this case, that's our protein per liter of solution. So if they want the molar mass, this is kind of what we're dealing with in our lab, then we really want the grams over the moles. We have the grams of the protein. So what I have to use the osmotic pressure formula for is to find the moles. Now, I have osmotic pressure, even though it's not in the right units, we'll have to convert it. I have liters, even though it's not in the right units, we'll have to convert it. We have R, which is your constant, and we have T. So we can plug in then straight into our osmotic pressure formula and solve for moles. Okay? So let's first convert our osmotic pressure to the proper unit. We cannot leave pressure in torr. We have to convert it to atmospheres. You may not know this, but in 1 atmosphere there are 760 torr. If you don't know it, it is something you will have to know. So to convert atmospheres to torr, 1 atmosphere is 760 torr, or vice versa. 1 atmosphere is 760 torr. So if we get our pressure, we have 1.12 divided by 760. Our pressure is 0.00147 atmospheres. That is going to equal the moles of solute over the liters of solution. I had a mil, so that's 0.001 liters, times your R, which is 0.08206 liter atmospheres per kmol, times your T, which is 298 Kelvin. Okay? So I will combine the 0.08206 and the 298, and I'm going to get 0.00147 equals X over 0.001 times 24.4538. So I'll divide both sides by the 24.4. Oh my goodness. And you should get X over 0.001 equals 6.0113 times 10 to the negative 5th. And then you cross multiply to solve for your X, and your X turns out to be 6.01 times 10 to the negative 8th moles. Okay, 6.01. That doesn't even look like 6.01. Okay, so now we can find our molar mass because we can take our grams, which we had up here, which were 0.001 grams. And divide it by our moles, 6.01 times 10 to the negative 8th. And we should get the molar mass of our protein. Oh boy, 16,635 grams per mole. That is a ginormous molar mass. And really, if we look at what was given to us, I think we only had 1 sig fig given to us. So if I put that in 1 sig fig, it's 2 times 10 to the 4th grams per mole. So this is a very large biomolecule, a very large hormone. But that is how we can get molar mass from osmotic pressure. That's it for tonight. Don't forget to do 48 and 58. Have a great night, everybody. Bye-bye.